we will only focus on how to find the expansion of certain functions only, which is exponential, log, and trigonometric functions. And from here, we can find how to approximate these three functions. Okay, so this is our focus. So, a power series, we can define it as the summation of a and x, a sub n x to the power of n, where n start from 0 up to infinity. Then from here, we expand this, we get n start from 0, we have a sub 0 x to the power of 0 plus a sub 1 x to the power of 1 plus a sub 2 x to the power of 2 up until a sub n x to the power of n and up to infinity. So this is the power series that is centered at x equals to 0. But if a power series is about centered at a, we write it as the summation of a sub n x minus a to the power of n, where n start from 0 up to infinity. So this is the infinite series. Same goes with this, but the difference is now we have a center at x equals to a. So when we expand this, we get a naught x minus a to the power of 0 plus a1 x minus a to the power of 1, a2 x minus a to the power of 2, and so on. Okay, then I forgot to expand this, so this will be a naught plus a1 x plus a2 x square plus an up until infinity. And this one will be a naught plus a1 x minus a plus a2 x minus a square, and so on. So for the power series that is centered at A, we will use this in Taylor series. So for this expansion of the three function, we will focus on using the power series as centered at x equals to 0. Okay, so now what you need to remember is this power series. Okay, I think it's just that you can simply just remember this, then you expand this into this form. Okay, now what we want to do is how to find the expansions of these three functions. The first one, we focus on the exponential, and then log followed by trigonometric. So for finding the expansion of these three functions, it involves 4 steps. The first one, we will express the functions into the power series, and then we will differentiate the equation with respect to x several times. This one depending on the questions. If they need to find the first 5 terms, then you maybe have to differentiate 5 times. Okay, depending on the function. So we will go through later. Okay, and then the step 3 is you have to let x equals to 0, and then from there we can obtain the coefficients value of a naught, a1, a2, and so on. Okay, and the last one, from the value of the coefficients, we substitute back into the step 1. Okay, now what we need to do is let's go through the first function, which is exponential. So how do we want to expand the exponential function? Okay, so first we express the exponential function by a power series where e to the power of x. So we take the basic exponential function, which is e to the power of x equals to the power series we centered x equals to 0. So it will be a naught plus a1x plus a2x squared plus a sub 3x cubed. Okay, then step 2 is we want to determine the coefficient of a naught, a1, a2 and so on. But before that, we need to differentiate the equation with respect to x. So first we differentiate both sides of equation with respect to x. So meaning that we have to find the derivative of ex equals to derivative of a naught plus a1x. Okay, so we get e to the power of x equals to a1 plus 2a2x plus 3a3x squared. This will be 4a sub 4 x to the power of 3. Okay, the next thing is we still have to differentiate again. So we differentiate this equation. So we have e to the power of x equals to 2a2 plus 6a3x plus, so this will be 12a4x squared. Differentiate again. So we have is plus 24x and again. So we stop here. Okay, so far faham tak this part? How to differentiate this? Okay, good. Okay, so now the next step is we have to let x equals to 0 in order for us to get the coefficients value. So the first one, so this will be the first equation. So e to the power of 0 will be equals to 1 equals to a1 plus 2a2x now is 0 and all are 0. So our a1 now becomes equals to 1. Next, substitute into 2. We have 1 equals to 2a2 plus 6a3 times with 0. So our a2 now is equals to 1 over 2. And proceed with the next one. Have 6a3 plus 24. And our a3 now is becomes 1 over 6. And finally, we have the last one, which is a4. So this will be equals to 1 over 24. So now we have all the coefficients value. Oh, but before that, we have a1, a2, a3, and a4. But we don't have the value of a naught. So how to get the value of a naught? Anyone? Macam mana dapat value of a naught? You all komen dekat chat ke? Alah, kenapa ni? Hello? Dengar tak?
Dengar doktor.
Dengar.
So macam mana nak cari A note? Kita dah dapat A1, A2, A3, A4 dengan
Dah satu.
masukkan value dalam yang differentiate ni. But how to get A note?
Dah satu.
Let X.
Tak boleh.
Let dekat atas ni. Is it? Betul lah kan? So, we substitute X equals to 0 in the first equation here. Equation ni. So, now we have our A note which is equals to 1. So, our A note is equals to 1. Okay, now what we need to do is substitute all this into the equation. So we have e to the power of x equals to a note which is equals to 1 plus, so our a1 now is equals to x plus a2 is x squared over 2 plus 1 over 6 x cubed, and then our a4 is x to the power of 4 over 24. So now our expansion of the exponential is equals to this. Okay. Okay, now let us try another example, which is I give you in the slide. So given the
Doktor.
here.
Tak apalah, tak ada. Selesai.
Okay, given the for this question, they already give you the expansion of ex. Okay, ex adalah in this form. Okay, now what you need to do is find the first 5 terms of the expansion of the following function. So the first one is you have to find e to the power of 2x. Okay, now what we need to do is what we need to do is we don't have to finding all the differentiation, all these 4 steps, because they already give you the expansion of the exponential function. So what we need to do is we just substitute our 2x into our x. So this will become 1 plus, our x now become 2x plus x squared, 2x squared over 2 factorial plus 2x to the power of cube 3 factorial and so on. Okay, so then we expand this, we have 1 plus 2x plus 4x over 2, we have 2x squared plus 1 over 6. So we have 4x cubed over berapa ni? 3. Okay. And then plus 2 kuasa 4 bahagi 4 faktorial. So we have this 2x to the power of 4 divided by 3. Okay, but what they ask you is to find the first 5 terms. So this is the first term, second, third, fourth, and fifth. So our answer will be up until the fifth term. So sampai sini je lah. So you don't have to find up until x to the power of 5 plus x to the power of 6. So just give your final answer up until the first 5 terms. Okay, so A is completed. Okay, what about B? E to the power of negative x. So for e to the power of negative x, same method, we just substitute into the expansion. So we have here minus x plus minus x square over 2 factorial, and then so we expand this, we get y minus x plus x square over 2 minus x over 6 plus x to the power of 4 over 24. Okay, so that is the expansion of e to the power of minus x. Okay, let's say this question is not 1 plus x e to the power of, it is 1 plus x e to the power of negative x. So what is the solution for this? How to solve this equation? We have the expansion of e to the power of minus x given like this. So how to find the expansion of 1 plus x e to the power of minus x? Do you have any idea?
Multiply.
Sorry,
I get
Multiply.
this.
apa dia?
Multiply.
Multiply, yes. So we just have to multiply this 1 plus x into the expansion of e to the power of minus x. So we have 1 plus x times with all this expansion. 1 minus x plus x squared over 2 minus x cubed plus this one. Then you multiply all this and get the first 5 terms of the expansion. Good. Okay, what if they didn't give you the expansion of this e to the power of x? Dia bagi kosong je. Dia cakap find the first 5 terms of the expansion of e to the power of 2x. Macam mana? So same. First thing first, kita akan cari the expansion of e to the power of x dulu by finding the power series, which is a1x plus a2x square. And then what you need to do is you have to differentiate this equation several times with respect to x, and then substitute x equals to 0. And then when you get the coefficients of a node a1, then substitute back into the equation and then find the e to the power of 2x dalam the expansion of e to the power of x. Okay. Okay, now we proceed with the so this will be the final answer for the last questions. But this one is I give you the example for e to the power of x squared. So you can try this later and try if you can get the same answer like this. Okay. Any questions so far?
No.
Good. Okay, now we go to the next function, which is log function. So log function, if we search for the power series of ln x, it would be impossible because if we differentiate, so ln x, okay, for ln x, we will also use the power series, which is equals to a naught plus a1x plus a2x squared and so on. But what will be difficult is when we differentiate ln x, we will have 1 over x, which will be a1 plus 2a2x. So when we substitute x as equals to 0, we have 1 over 0, which is undefined, which does not exist. So we cannot use the log of ln x. So what we can find is instead of using ln x, we use ln 1 plus x. So from here, then find the derivative of this equation. So this will become 1 over 1 plus x. Now if we substitute x with 0, we will get the answer which is 1. So we don't have any problem with that. So the next step is differentiate this. We have a1 plus 2a2 plus 3a3x squared and so on. And then we differentiate again. So we will have negative of 1 over 1 plus x squared will be 6a x plus this, and then continue with the next derivative, which will be 2 over 1 plus x to the power of cube. So if you need to find the uh, derivative, lagi banyak derivative that you need to find, so the longer expansion you need to write here. So this should be a for x to the power of 4, and this will be 4a to the power a sub 4 x to the power of cube, and this would be 12 this will be 24 equal x. So the same method where you have to substitute x equals to 0 into this equation to get the value of a0, a1, a2 and a3. Kenapa jadi a3? It should be 2a2x. Okay. Silap, sorry. It should be not this one. Should be 2a2 plus 6a3x. Will be 6a3. Okay. Now we find that when x equals to 0, So we have here is ln 1 which is equals to so our A naught will be equals to 0. So the next one is substitute into the second one which will be 1 over 1 plus 0. So our A1 is equals to 1. And then same goes with this third equation. Have equals to 2A2. So our A2 now is equals to half. And the last equation will be 2 over. So our A3 is equals to 1 over 3. So now our ln 1 plus x comes not 0. So our A1 is x plus A2 is A1 is x minus x squared over 2. Our A3 is now becomes x cubed over 3. Okay. So now we already solved how to find the expansion of the logarithmic. Okay. So let's say you want to find, here is ln 1 plus x. So let's say you want to find ln 1 minus x. You just substitute x with negative x. So our here will be negative x squared, negative x cubed, and so on. So the final answer will be in terms of this. Okay. So let us try the first example. Write down the first 5 non-zero terms of the expansion of the ln 1 plus 2x. So what is the idea of this? What can we do?
Use the same equation. You're replacing 3 with instead of x, 3x.
Yes, correct, Amma. So we just substitute into the expansion, which will be 3x minus 3x squared over 2 plus 3x cubed over 3. But here we only have up until 3 terms. So what you have to do is you have to expand this power series into a5x to the power of 5, a6x to the power of 6, up until 6, and you have to differentiate until you get the fifth term. So this will be 1, 2, 3, 4, and 5. And you can get the first 5 terms of ln 1 plus 3x. Okay. Same goes with this one. Since we already have the expansion of ln 1 plus 3x, then you just multiply with the this 1 minus 2x. Okay, so next you can try this too later. Okay, now we go through to the last function, which is trigonometry. So let's say we want to find the expansion of cos x. So cos x will be expressed in terms of power series, in terms of this, and then we differentiate both sides. We get this negative sine x equals to this, And then we differentiate negative sign x, we have negative cos x, and so on. Okay, and then the next step is we substitute x equals to 0 into the equation, and we have the value of a naught, a1 up until a4. Okay, then we substitute back into the power series, and we get the expansion of cos x, which is in terms of this. Okay, so the same method just involve 4 steps for the expansion of the functions. Okay, now I want you to try this example. Try this together. Okay, since you already know how to find the expansion of cos x, we just use this expansion. So let's say you have found the expansion of this. So what you need to do is just substitute our 2x into the series. So we have 1 minus 2x squared over 2 plus 2x to the power of 4 over 4 factorial, and then this will be 2x to the power of 6 over 6 factorial. And we expand this. We have 1 minus 2x squared, then this will become 2 third x to the power of 4. Then this will be 4 over 45 x to the power of 6. And the last one will be 2x to the power of 8 over 315. So this is the expansion of cos 2x. Okay, now we have find the expansion of cos 2x. Hence, by using an appropriate trigonometric identities, find the first 4 non-zero terms of the expansion of sine square x. Okay, what can we do here? How to solve this? From this expansion, we want to find sine square x.
We substitute it into x.
We substitute into x. But this, how we want to substitute into x, since this is the expansion of cos x. Okay, the trick is they already asked you to use the trigonometric identities. So if you when you refer to the identities formula, you will notice that cos 2x, there is one formula that involves cos 2x, which is equals to 1 minus 2 sine square x. So from here, we just we reorganize this. We will get sine square x, which is 1 minus cos 2x over 2. By this, we got in terms of this. Kan? So from here, we already solved the cos 2x. We get the expansion of this. So just substitute into this cos 2x. So we have 1 minus 2x squared plus this first 4. So we have 1, 2, 3 minus 4x to the power of 6 over 45. So now what we have is 1 minus 1, which will be 0. So this will be 2x squared minus 2 third plus minus, then we simplify again, we get x squared minus plus 2 minus x to the power of 8, 315. So this is our expansion of sine squared x. Any questions?
No, thank you, Miss.
Okay, good. Okay, so that's all for power series. I want you to try this example, this exercise, okay, by using the same method. Show that the expansion of sine x is in this form. Atas sikit kat sini ke? Okay. So I want you to try this exercise, but just find up until the first non-zero, the first three non-zero terms. First three zero terms. So just move up until x to the power of 5. Try this out. Okay. Okay, so that's all for today. Next class we will learn about the convergence and the divergence test and the Taylor series. Okay, but before that, I want to give you assignment 1. So for assignment 1, this is the group assignment. Nampak tak yang ni? Can you see this assignment?
But
Yeah.
Okay. So you have to get at least 4 to 5 members per group, but make sure you are all the same section. You cannot mix section 1 and section 2 in a one group. Okay, so this is the template. So you have to fill in your name, matrix number, and signature, and choose my name, which is, this is my name, Hafiza Farha. So choose whether you are from section 1 or section 2. Okay, so the due date is on the 30th November. I will give you the link of submission. Okay, so for this part, you don't have to fill in this form. This is filled in by me. But you can see the criteria of the assignment, which is based on the topic knowledge, the method, analysis, and interpretation of results. Okay, so this is the questions. You can go through later. I will upload this in the e-learning. Okay, so you have 4 questions. And please answer all these questions. Okay, and then you don't have to type your assignment. You can just use your handwriting, but make sure that it is, I can see your writing. Please don't use pencil. Okay, please use pen. Okay, so any questions for assignment? Do you have any problem to find the members?
Sorry, doctor. May I ask that is it okay if we type in?
Yeah, also can.
Alright, thank
Tapi
you.
rajin ke? Kalau you rajin, okay je. Any more questions?
Seorang satu kena hantar
No, thank you, doctor.
Sorry?
atau dia semua setiap seorang tu kena hantar ataupun hanya satu?
Oh, only submit one solution. One assignment je. Ketua je lah yang hantar sebab I already know your group members kan. So it doesn't a big problem lah.
Okay,
Only one submission for each group. This one. Submit only one set of solution for each group.
okay, thank you.
Okay. Any more questions? So the questions will be on the differentiation, integration, improper integrals, and the power series. Okay. So if you don't have any questions, we can stop now.
Doctor, but I have one more question.
Yeah.
When is the deadline
Louder,
for
please.
this assignment?
Sorry. Louder, please.
Doctor, when is the deadline?
The deadline. The deadline is on 30th November, on Monday.
Yeah, all right, doctor.
Okay.
Thank you, doctor.
If you have any problem finding members, you can just post in the group. I think just find anyone who's still not in the group. Okay. So that's all for today. Okay, thank you. I give you the attendance link in the WhatsApp group.
Okay, thank you for your time, doctor.
You're welcome.